So the one slide that was cut out of the notes is this one here. So this here is our property of equality for exponential equations. Well, our word equality means what? Equal. So if the bases, if b is a positive real number other than 1, then b to the x is equal to b to the y if and only if x is equal to y. So if the two bases are the same, then the exponents have to be equal to each other. So if we have 3 to the x is equal to 3 to the 5th, well then x is equal to 5. Because for them to be the same, the exponents have to be the same. Now if the bases are not the same, we need to be able to make them. And all the ones that we're going to deal with today, we can rewrite the base as and have them be the same. So we'll deal with a few that the bases are not the same and rewriting them, and then we'll deal with some that are. So this here is the first problem, the first one on the note sheet, is we have 100 to the x is equal to 1/10 to the x minus 3. And now what I want is the bases to be the same. So I want to be able to rewrite 100 and 1/10 as the same number. Well, we can rewrite 100 as what? Number to a power. I can rewrite 100 as what? 10 to the 2. Because 10 squared is 100. But we can move the 10 and 1/10 from the denominator to the numerator. So, yeah, we only had one slide out of order. I'll get it fixed for next year. But when we move the 10 from the denominator to the numerator, the exponent's going to change from positive to, and it'd be -1. Because 10, any number that doesn't have a written exponent is always understood to be 1. And if we move something from the bottom of the fraction to the top or the top to the bottom, the exponent goes from positive to negative or negative to positive. And the reason we did that is now I have both of the bases on either side are both 10. They're both the same. So it means that the exponents have to be the same as well. Well, before we start setting them equal to, it might be nice to just rewrite it. Because here, 10 squared to the x, well, powers of powers multiply. So 2 times x will be 2x. Now 10 to the -1 to the x minus 3, well, we're going to need to multiply x minus 3 by -1, which would give us negative x plus 3. Any questions on any of this here so far? Well, the bases are the same, yes? So the exponents have to be equal also for these to be equal. So really, we can say that 2x is equal to -x plus 3. So you can write it down below, that's fine. I'm just writing it off to the side. And now we just need to solve for the value of x. So what can we do first? We can add x to both sides. Because -x plus x would be 0, leaving us with just 3 on the right-hand side. And 2x plus x is 3x. And last but not least, we can both sides by 3, which tells us x is equal to 1. And that's it. Any questions on any of this here? And if we wanted to check it, we could plug 1 back into our original problem for x on both sides, and we'll see that they will be the same thing. They'll give us the same value. Any questions on any of this here so far? Let's look at the next one. So we have 5 to the 3 minus 2x is equal to 5 to the negative x. Well, here the bases are already the same, yes? So we can set the exponents equal to each other. It'd be the same as 3 minus 2x is equal to negative x. So what can we do first in solving for x? We can add x to both sides, or we can add, I'm going to add 2x to both sides. Because negative 2x plus 2x is 0, giving us just 3 is equal to, well, negative x plus 2x is, it just gives us 3 is equal to x, or x is equal to 3, and we have it solved. We're done. Because we could go the other way and we can add x to both sides. And we would get the same answer. Because these would cancel, give us 0. 3 minus x is equal to 0. So we can either add 3 or subtract 3 from both sides. Negative x is equal to negative 3, or x is equal to 3. So the order in which we add or subtract or move things really doesn't matter. We just need to see which one we want to do first. And it just works out adding 2x to both sides actually is a lot faster. Any questions on any of this here? Three to the 2a is equal to 3 to the negative a. So the bases, are they already the same? So we don't need to do anything about that. So we know that 2a is equal to negative a. The exponents have to be the same since the bases are already the same. So what can we do next? We can add a to both sides. And if we add a to both sides, we get that 3a is equal to 0. Where can we go from here? We can divide both sides by 3. Which tells me a is equal to 0. Well, really, once we get 3a is equal to 0, our zero product property, we can use it because any two things multiplied together that equal 0 means that one of them must be 0. Well, 3 can't be 0 because it is 3, so it means a has to be 0. Any questions on any of this here? We're good with this here so far? Yes? Not too bad? Solve each equation. So we're going to solve this here. 2 to the 2x plus 2 is equal to 2 to the 3x. Now, at this point here, we can see that the bases are the same, yes? So that means the exponents would be equal. I'm going to do something a little bit different. If you've already written down that 2x plus 2 equals 3x and already started that, that's fine. You don't have to write these first steps. Because what I'm going to do and what I'm going to show you with these first few steps is really the reason why this works. Now, what we've went over on Monday is that if I apply log base 2, I take log base 2 of both sides of this equation is what I'm going to do first. Now, this here, you don't have to do this method because especially if the bases are the same, we won't approach it this way. Now, our power property that we talked about on Monday said that I can take the exponent of whatever's inside. If whatever's inside the logarithm has an exponent, we can take it and move it out front, which means I can move both of these out front. So for this one here, we would have 2x plus 3 times log base 2 of 2 is equal to 3x times log base 2 of 2. So that's just our power property. We used it on Monday. We worked with it then. Now also on Monday, we talked about if the base and what's inside the logarithm are the same, they simplify out. It simplifies to 1. So that becomes 1. This becomes 1. And if we multiply something by 1, well, it's just whatever we have. So really this here, just 2x plus 3 is equal to 3x. Well, that's what our equality, our exponential equality, has stated. Because the bases are the same, it means the exponents have to be equal. This is the reason why. Because if I take log base 2 of both sides, matching with the base, they will simplify out, leaving us with just the exponents. That's why this property works. Any questions on this here? All right. Well, let's solve this in one step. What would we need to do? Subtract 2x from both sides. As 2x minus 2x would be 0. 3x minus 2x is just x equals 3. Two. I think I wrote the problem down wrong, didn't I? Yep, I wrote it down from the start. Or not start, but that should be plus 2, which would give us 2. Yes. Thank you. Transcription error. Besides the typo, are there any other questions on this here or how these work? Do you feel comfortable with these here? Let's skip that one and let's look at this one here. So we might end up skipping 2 because we do have that random homework question slide thrown in. So we're looking at this one here. 6 to the 3m times 6 to the negative m is equal to 6 to the negative 2m. Well, the bases, we have 3 of them, but they are all the same, yes? So for our 6 to the 3m times 6 to the negative m, these here, the bases are the same, so we can do what? Do something with the exponents. So what can we do with the exponents if the bases are the same? We can add them. Because if the bases are the same, you add the exponents. So what's 3m plus negative m? 2m. Because 3m plus negative m, or 3m minus m, would be 2m. At this point here, we do have the bases being the same thing. So we can say 2m is equal to negative 2m. Now we just need to solve for the value of m that will make this statement true. So the first thing we can do is what? We can add 2m to both sides. And negative 2m plus 2m would give us 0. And 2m plus 2m would be 4m. And from here we can, by 4, telling us that m is equal to 0. M is equal to 0. Any questions over any of this here? Okay. All right. Let's look at this one here. Now this one here, just like with the first one we dealt with, we don't have like bases. Because one of the bases is 3 and the other is 243. So if I were to solve this like we've been solving it, I really want to be able to write 243 as 3 to a power, 3 to an exponent. Now there's different ways we can go about trying to find this. One of them is that I can take 243 and just start dividing by 3 and see how many times I need to divide by 3 to hit 1. Or we can go in the opposite direction and just start putting 3 to exponents or multiplying 3 by itself and seeing if I eventually hit 243. Well, 3 squared is 9. If I multiply 9 by 3, I get 27. 27 times 3 is 81. And 81 times 3 is 243. So it would be 3 to the 5th. 3 to the 5th is 243. And we can do that in a calculator or just essentially multiplying by 3 to see where we get to. Any questions on this here? So are the bases now the same? So we can set 1 minus 2x is equal to 5. And now we just need to find the value of x that will make this true. So what can we do first? We can add 2x, yes. If we add 2x to both sides, these will cancel. And it'll give me 1 is equal to, I'll move the 2x in front, 2x plus 5. Now what do we need to do next? So we want to get 2x by itself. So we can subtract 5 from both sides, because 5 minus 5 will be 0. Well, 1 minus 5 is -4. And last but not least, we need to divide both sides by 2. 2x divided by 2 is going to be x. And -4 divided by 2 is -2. And that right there is our answer. And it doesn't really matter that x is a negative. We can have negatives in exponentials. We can have a negative exponent, and that is perfectly fine. We'll be ready for the next one. So this one here is combining one that we did earlier with the one we just did. Now, since 4 to the 2, we have 4 to the -2x times 4 to the x equals 64. Well, since 4 to the 2x and 4 to the x both have the same base, we can do what? We can add the exponents. So -2x plus x would be what? Would be negative x is equal to, well, as we've been working these, we need to be able to write 64 as 4 to a power. And 4 to what power is 64? 4 to the third would give us 64. Now, since we do have like bases, we can say that negative x is equal to 3. And what do we need to do next? Well, we can divide both sides by -1, or multiply both sides by -1, which is just telling us x is equal to -3. Any questions on anything we've done so far? So really a lot of what we're doing here is just rewriting both sides so that the bases are the same. Because if I can get the bases the same, then we set the exponents equal to each other. So this here is very much like the first one that we did. So what do we want the base for each one of these to be? Or what's a nice number that we can use for 81 and 1/9? 9. Because if we wanted to, we could use 3, because 3 to the 4th is 81, 3 squared is 9. But 9 squared is 81. So 9 works better. Now if this 81 had been 27, then I would have used 3, because we cannot write 9 to a power and get 27. But we can with 3. So what we can do with this here is we're going to rewrite 81 as 9 squared to the x is equal to, for our 1/9, we would have 9 to the what? -1. Is for me to be able to move the 9 from the denominator to the numerator, we have to change the exponent from positive to negative. Now here powers and powers multiply, so we have 9 to the 2x is equal to 9 to the -x minus 3. Because we have to multiply x plus 3 by -1, which will change the sign of both. Any questions on any of this here? Well, since the bases are the same, we can set the exponents equal to each other. So we have 2x is equal to -x minus 3. And now we just need to solve for the value of x. So what's the first thing we can do to both sides? We can add x to both sides. This -x plus x will cancel, and 2x plus x would be 3x equals -3. And then we would divide by 3, minus x is equal to -1. And that's all we have to do on these here. Any questions on any of these here before we look at our next property of equality? We feel good with these here? Okay. Now our next property of equality is the property of equality for logarithmic equations. So if b, x, and y are positive real numbers with b different from 1, then log base b of x is equal to log base b of y if and only if x is equal to y. So if the two logs are the same, we can set what's inside equal to each other. So here x is equal to 2. Now if we look at this first one here, Well, I have a natural log and a natural log. They are the same, yes? So since they're the same, we can set what's inside the logs equal to each other, yes? Now, I'm going to write an additional step. You do not have to write this, because I think most of you all have already written that 4x minus 7 is equal to x plus 5, yes? Because they are equal. Now, the reason that this works is because if I put both sides to the e. On Monday, when we covered the fact that log base b of b does simplify out completely, we also went over the fact that b to the log base b of x, b to the log base b of x, is just equal to x. They will simplify out also. Now for natural logs, the base is e. It's understood to be e. So these here will simplify out. These here will simplify out, really leaving us with 4x minus 7 is equal to x plus 5, which is our property or equality property of logarithms, or property of equality of logarithms, is what it tells us this is here. Now we don't have to use that e step here because we know the logarithms are already the same. We can just go on and set them equal. Any questions on this here so far? Well, now we just need to solve for the value of x. And the first thing we can do is we can get x on the same side. I'm going to subtract x from both sides because it keeps the power of, or number in front of x positive, because 4x minus x is 3x, and we have minus 7 is equal to, well, x minus x is 0, so we're just left with 5. Well, we still need to get x by itself, so we can add 7 to both sides, which tells me 3x is equal to, well, 5 plus 7 is 12. And last but not least, we need to divide both sides by 3. So x is equal to 4. Any questions on this here? We like this here so far? I'm going to skip that one because I feel it like at this point, y'all get this. Essentially, this is not so much really solving logarithms as it is multi-step equations. Because with natural logs, or this one here, this logarithm, all we're really saying is that 5x is equal to 2x plus 9. Because the logarithms are the same, what's inside the logarithms has to be equal as well. And now we just need to solve for the value of x. So what can we do first? We can subtract 2x from both sides. Well, 5x minus 2x is 3x is equal to 9. And then what do we need to do next? We need to divide both sides by 3, which tells us x is equal to 3. And that's it. Now, with logarithms and solving logarithms, there's one thing we need to be careful with, and that is that we cannot have a negative number inside of a log. And that's not saying that the value of x cannot be negative. It's just that when we plug x back in, let's get a highlighter, in here or here, and what I get is a negative number, then it doesn't work. Because if it worked out that I got -1 and we plugged it back in and I got that both of them were 2, I have log of 2 and log of 2, we're fine. Because I do not have a negative number inside of the log. It's not log of -2, it's just log of 2. But if it ends up I plug it back in and we get, don't need to be writing with a highlighter, log of -2 is equal to log of -2, this does not work. We cannot have a negative number inside of a logarithm. They do not work. We cannot have it. And the reason behind that, the reason we can't have a negative inside of a log, is because if we have log base b of -2 is equal to x, according to our properties of exponents, if we rewrite it, it would be b to the x is equal to -2. This does not work. Because no matter what this base is, it cannot be a negative number. It does not equal a negative number. Because if we said x is negative, if I have b to the -x equals -2, well, this is just the same as saying 1 over b to the x. Well, we don't have any negatives anymore, and really this here will just approach 0. And if we looked at it graphically, if we remember back when we first started talking about these, exponential growth and decay, that b to the x never went below 0 unless we subtracted something from it. So the natural log, just b to the x, if we said b to the x doesn't equal here, or b to the x equals y, it never drops below 0, so that means it can never be equal to a negative number. So if y can't be negative, and y is here, what's inside a logarithm can never be negative, because I can't have an exponential function equal a negative number. Does that make sense? So that's one thing we need to be careful of and be looking out for. So if our solution, whatever it is, when we plug it back in, gives us a negative number inside the log, it doesn't work. It's what we call an extraneous solution. But are there any other questions on any of these here? Or do we feel comfortable with these here? Yes? All right. I will give you the remainder